Okay, everybody, let's recap the lesson. So I'm on page 458. We're talking about exponential functions. So we started out this whole lesson about this story problem where this legendary inventor who invented chess said, well, pay me 1 grain of rice, and then the next day for the next square 2 grains, and then 4 and 8. And we've seen this problem before where it really grows fast. And so 16, fill out the chart, 8, 16, 30. So it's just doubling every time. So, all right, so as a geometric sequence, which we've talked about before, this formula would be g of n equals 1, because we start with 1, times 2 to the n minus 1 power. Okay, so then we graphed it. You see the dots?
Holt Walker, please,
dots.
to the office. Holt Walker to the office, please.
And then what we know is that I connected the dots, but in a sense, if it's a sequence, you do not connect the dots. It's a sequence, you don't connect the dots because you got 1 grain of rice, 2 grains of rice, 4. You're not supposed to really have half grains of rice, or first term, second term, third term. So if we want to change this geometric sequence into a function, we connect the dots. So if we connect the dots, one of the things that happens on this is that we end up with a y-intercept. A geometric sequence does not cross at 0 because you got your first term, but a function will. So we say, okay, well, we need to find that and change this formula into this formula, okay? So we connect the dots, and we know that it's got to go through 0. So how do we find that, okay? So the exponential function is a little bit different. We know that if we look at the chart, we're always going down by halves. We get to 1, so the very first term would have to be 1/2. So the y-intercept would have to be 1/2 times 2, that's the multiplier, to the x power. So these two are the same kind of graph with a couple of exceptions. Okay, the sequence is just the dots. No in-betweens, just the dots. And the sequence doesn't have a 0 term or it doesn't connect, okay? So then we go, okay, well, if that's the case, can we change this function, g of n equals our 1 times 2 to the n minus 1 power into a function? Well, the way we do it is this. We rewrite it. And we change our 2 to the n minus 1 power into 2 to the n times 2 to the negative 1, okay? So that's the same exact expression, it's just split up. Now 2 to the negative 1 power, we used our calculator, turned out to be 1/2. So it's 1/2. So this number is 1/2. So put 1/2 here. So I rewrote it as, instead of 2 times to the n minus 1 power, it becomes 1/2 times 2 to the n, okay? All right, now, we turn the page, and we looked at the fact that, sure enough, we can take a look at a different function, okay? So here's a geometric sequence, 45, and we want to rewrite it as a function. We want to write it as a function, okay? So we wrote this 2 to the n minus 1 power is 2 to the n times 2 to the negative 1. We know that 2 to the negative 1 is 1/2, so then we rewrote this as 1/2. So now we've got the 1/2 times 2 to the n, half of 45. Half of 45 is 22.5. So here's my function, f of n, my function, as the exact same kind of equation as my geometric, okay? So then we did a few more practices, okay? So we took this one, we changed the geometric to a function. We took 3 to the x minus 1, we changed it to 3 to the x times 3 to the negative 1. 3 to the negative 1 is 1/3. So then we took the negative 2 times 1/3, and we got negative 2/3. These two are the same. One's a function, one's a geometric expression. So we saw this one earlier, 45 to the negative 1. So we changed the 2 to the x minus 1 into 2 to the x to the negative 1. Okay, we just broke it up. 2 to the negative 1 we know is 1/2. Half of 45 is 22.5. Okay. Now this one's a little weird. So we took the 0.1 to the x and 0.1 to the negative 1. It turns out that turned out to be 10. We tried our calculator, but this right here, 0.1 to the negative 1, turns out to be 10. In fact, if we check that on the calculator, I'll show you what I mean. Here, hold on. Let's clear. There it is. 0.1 to the negative 1 power is 10, all right? So we wound up with 10, and we multiplied 10 times by 1,234, gave me 12,340 times 0.1 to the x, okay? And then finally, we looked at this one. We took 1/2, we changed it to 1/2 to the x, and 1/2 to the negative 1. Turns out that 1/2 to the negative 1 power turns out to be 2. So we took the 2 times the negative 5, we got 10, negative times 10 times 1/2 to the x, okay? So we changed things. Our whole goal is to change it from an explicit formula to a function, and with a function that we can graph it, we do know it's an exponential function. So that's all I have. We had a homework assignment. We did skills 197 to 199, okay? And we also had a mathia. Okay, that's all I have for you. If you have any questions, come see me.